For our last session of the day, I'd like to welcome Shiva Zargar. She's with Build Neutral. In what I do at FenCan, obviously sourcing speakers and presenters and content, Shiva and my paths crossed at Top Class West. Was it last year, I guess, right? When she was part of one of Patrick's panels, and I thought, I got to write down her name because she's going to be really, really beneficial for our industry and for Fenestration Canada. So we connected. She's been working with Adrian, who is working on a project with NRC on EPDs and LCIs, along with Jomo at Leighton. We're putting a project together currently that is going to be developing LCIs, EPDs, PCRs. No EPDs. Okay, sorry. Anyway, working on a lot of the embodied carbon metrics and that around fenestration and pulling that project together. So really happy to have her with us today. She's going to be talking about her work on embodied carbon and LCAs, et cetera. So Shiva, welcome.
Thank you so much, Terry. Hello, everybody. Thank you. So happy to be here. My name is Shiva. A little bit of background about me. I'm a co-founder and director of science and LCA, life cycle assessment at Build Neutral. I'm here today with my business partner, Racy Cryer from Samson Cree Nation. He's an expert in standard and policy, and if you have any questions about the standard and policy, he's gonna answer it for you. And I'm the science person in our team. My PhD focused on life cycle assessment and techno-economic analysis and all of this stuff. I also have 2 master degrees. In both of them, I work on life cycle assessment. I got my PhD at UBC Vancouver and one of my master at UBC Kelowna. So based on all these life cycle assessment education from academia, I was like, I'm gonna go be a consultant helping our community and industry to see how they can use this science, knowledge, methodology in real world. And today I'm going to talk about environmental product declarations, EPDs. Okay, what is an EPD? It's a third-party verified document that discloses the environmental impacts of your product or process through its whole life cycle, from raw material extraction to transporting, to manufacturing, to the use, replacement, etc., recycling, landfilling, and it is third party. I develop LCA and EPD. Another scientist, an expert in the field of EPD, is gonna verify my work to make sure everything is accurate. So you have seen lots of these calorie information, nutrition label. You go buy a yogurt. One yogurt says 200 calorie for 2/3 of the cup. Then you look at another yogurt. It has a half a calorie, but for 1/3 of a cup. So that cup size is the functional unit, which makes it hard for you to compare because they are not providing the same function. That's why EPD are here. And on top of the EPDs, we have PCRs that tell us what are the rules, what is the function. So you would be able to compare. Yogurt, easy. This is the calorie based on 1 cup. The other yogurt, this is the calorie based on 1 cup. And in EPDs, instead of the calorie and fat and sugar, etc., you are having the environmental impacts, global warming potential, acidification, eutrophication, all the potential impacts of your process of producing your product. And now why we need EPDs? Because we are seeing in LEED, in Green Building Certification, BREEAM, they're requesting. There are some customers that would like to report ESG, environmental, social governance, or they are having LEED target, they're using EPDs. We are having whole building life cycle assessment that requires EPDs. And then on top of that, we have this Bill C-59 in Canada that tells us we shouldn't do greenwashing, which I'm going to go into it. So in the LEED V5 that came recently, it says for new construction, we need EPDs. It has a point. For core and shell, again, we need EPDs. And I put it in here as a quantify the reduction of embodied carbon of major structure, enclosure, and hardscape materials. And then it says, result must be based on embodied carbon intensities of material as constructed. So like this whole EPD is really gonna help people to get all the points they need for LEED or other certificates. And then in Canada, we have this standard or embodied carbon in construction. And in section 3.2.3, we are having, please include the following requirements in the procurement of construction services. Ensure that embodied carbon disclosures for structural materials are secured by the organization before project completion, and that they list the required information for each type of material identified in Appendix B, and then disclosure the embodied carbon footprint, etc., EPDs. So if you want to sell your product on the government project and you want to follow these standards, here EPD comes for you. And then Bill C-59 tells us that when you are talking about the sustainability of your product, your business, you can't just say, my product is sustainable. My product is net zero. My product is neutral. These are all greenwashing. You need to have backup data for your claim that is internationally recognized methodology. And the good news is that EPDs and LCAs, life cycle assessment, environmental product declarations, they are internationally recognized methodologies. So, purpose behind EPDs: shift the market to lower impact products. Customers are demanding, then as manufacturer, you are going to produce the products that have lower carbon emissions. Then you are going to reach out to your suppliers. Please provide me with your most sustainable low carbon emissions product. So this is going to go on, and hopefully we are going to have products with lower environmental impacts. EPD provides verified comparable facts. The whole point of these EPDs are like for us to see, okay, we have this window and that window, how we can compare them. That's why we have PCR, product category rules, that moving forward, I'm going to talk about all of these in details. But the goal is to compare different products with each other if they are apple to apple, like this window with that window. Derive continuous improvement. So as LCA scientist, I will give you options. Like this is the hottest spot in your supply chain. Like your transportation brings the highest emission into your system. Or your scrap rate is high. Would you like, we worked with each other to reduce it? So continuous improvement on your environmental impacts. And support codes, claims, credits, and enable informed design and procurement decisions. So I just wanted to be unbiased, just search for some EPDs, and I found these. There are many more EPDs when it comes to fenestration. So we have EPDs for fiberglass, for processed glass, laminated, PVC windows, decorative laminated glass. Like, you know your industry, you know who are having EPDs and who are not. But all of those that I showed you are third-party verified. So this is the ISO standards we have to follow for developing EPDs. 14025 talks about all the rules that must go into EPD development. So type 3 environmental declarations, principles, and procedures. On top of that, for construction materials, we have 21930. Because I'm saying construction materials because PCR and EPD can be used for any industry. It's not only for construction. So if the material is construction, we have 21930. And then we have 14020, which is talk about principles and general requirements for environmental statements. So everything is internationally recognized methodology. So check the box for Bill C-59. And then in the heart of our EPD, we have life cycle assessment, which is based on ISO 14040 and 14044. So developing those have to follow all these rules and standards. So what is life cycle assessment? It has 4 main phases: goal and scope definition, life cycle inventory, life cycle impact assessment, and interpretation. In the goal phase of your study and the scope, you need to disclose what's the goal. Do you want to disclose the result to public? Do you want to compare your product with another product? Do you want to develop EPDs based on these LCA results? What's the function of your product? Are you calculating these results based on 1 square meter of window, or let's say like 1 kilogram of the weight of the glass, let's say? So you have to be as transparent as possible in the goal stage, because the result directly is impacted by goal. What is the limitations? What are the assumptions going to this system? Are you producing multiple products? If you are doing that, we call it like co-products, and then as a LCA modeler, we have to consider different allocation. So all of those coming at this stage to be defined. And then we have life cycle inventory. What are all the inputs and outputs of your products? Like, does aluminum comes? Paint comes, sand, you name it. You know better than me what comes to your system, how much electricity you are using, what's the transportation of material A to your factory, material B to your factory, etc., etc. All comes to this section. And what are the outputs? And then we transfer all those life cycle inventory data to the potential impacts at this life cycle impact assessment stage. But life cycle assessment is an iterative process. I know at the beginning we say, okay, this is a goal of my study, but based on the data, you might need to change the goal of your study when it comes to LCA, not EPD. And then at the end, we are interpreting the results. You see, like you might have read some EPDs, see global warming potential. Great, 40 kilograms CO2 per square meter of this window, but based on what? So in the interpretation stage, the LCA scientist is telling you this number is based on these assumptions, based on this quality of data. We couldn't access, for example, the primary data, and we use literature. So you will see what's the quality, what's the assumptions, limitation, etc. in that interpretation stage. And it has a direct application: product development and improvement, strategic planning, public policy making, marketing, etc. For example, you do an LCA for your product, we find a hotspot, you pay attention. Instead of just using the number that this is our global warming potential, you want to reduce that number and pay attention to the hotspot. So your marketing team can say, this is our, for example, scenario analysis, and we were doing this process. Now we did the LCA, we found out this is our hotspot, and we reduced it. We are paying attention to environmental impacts of our products. When it comes to LCA, we have cradle to gate, cradle to grave. This is again the scope that we need to define it at the beginning. My study stops at the gate of my factory. I don't care how the customers are going to use it. Or I'm paying attention to the use phase, how many times this product is going to get replaced, what's the maintenance. At the end of the life of this product, can we recycle it? Can we landfill it? If we recycle, landfill, what is the environmental impact? So that's cradle to grave. So we have material extraction, and then we have transporting them to the manufacturing. We have all these equipments use energy at the manufacturing level. my product is done, I have to transport it to the construction site. And in the construction, how I'm installing it. Is the manual installation? No. Do I need energy? What other material I'll need for installation? If it's a floor, for example, do I need adhesive or not? All these come to the calculation. And my material lasts only 10 years, but the life cycle of the building is 60 years or 75 years. How many times I need to replace my product? So we are considering all of these when we are talking about cradle to grave. So we reach the end of life of our product. What I can do for it? Do I have a take back program, or the material can be recycled or landfill? We can evaluate all of those. So life cycle assessment itself for each stage, again, has ISO. ISO 14041 talks about the goal and scope definition and inventory analysis. 14042 focuses on impact assessment. And 43 focuses on interpretation. So now, the fun part, how to create an EPD. So we know that the heart of EPD is LCA. But let's come back, look at it. We have program operators that they're responsible for managing this entire EPD program. They are responsible for developing PCRs. What is PCR? Product Category Rule. So LCA gives me lots of options. I can consider cradle to gate. I can consider cradle to grave. I can consider whatever functional unit I want, right? But product category rules comment gives me more rules for a specific product. So when I develop EPD for a window, I expect when I follow that PCR, another EPD that followed the same PCR to be comparable with mine. If it's not, that PCR needs to be improved. Because based on ISO, the comparability is critical when developing PCRs. So we have program operators responsible for developing PCRs and accrediting EPD verifiers. So for example, as I'm also an EPD verifier with CSA group, I had to go through the process to be EPD verifier. You have to show your resume, your experience in lifecycle assessment, in critical review, in EPD, all of this. So they are responsible for all of this, and then they also publish the EPD on their website. And then, great, we have the PCR. So based on that PCR, we can develop the EPD. But first, we need to do an LCA based on the PCR. LCA is done. LCA, let's say, is 100-page of report. It gets summarized in 10-page of EPDs that you are seeing out there. It's public, everyone can read it. That LCA report that we have to submit alongside that EPD report is confidential. Some manufacturer might want to disclose it, some might not, but all the data, many assumptions, limitations, what background information, background data I'm using is in that LCA report that the third-party person reviews it, asks questions that why you chose that proxy, why you consider these assumptions. And then as a EPD developer, I have to answer them. Otherwise, that's not gonna get approved. And I have to have reference, citation, all the equations. Am I following mass balance, energy balance, etc. And then after hopefully 2 rounds of reviews, that EPDs get verified and then it gets registered and published. So it's a long process, but we do it. So these are some of the program operators we have right now. It's we have UL Solution, a Smart EPD, EPD International, CSA Group, NSF. And then they are responsible for developing product category rules. They usually have part A, some rules that tells me how to develop all those LCAs, what should be my assumptions, data quality, like etc. And then we have part B for different products. For example, for floor, for cement, for concrete, for window, for sealant, for anything you name it. They develop those PCRs. So here I put process glass EPD requirements. I put PCR for fenestration assemblies. I put building and construction sealant EPD requirements, and I put requirements on the EPD for windows, doors, and facade systems. As you see, there are so many EPDs. So then I put some other type of PCR here that you see is just not for construction. Like we have PCR for luggage and handbags, for office furniture, for biochar. It's like this LCA life cycle thinking mindset can be applied to anything. It's like shared food. We have project on like beverages, like alternative coffee. It can be anything. So on PCRs that are probably you found out it's a key part to develop EPDs because it tells us all the rules, right? I, as a LCA scientist, sit on those committee. And if a PCR related to fenestration is developed, you as a manufacturer should sit on those committees because you can share your, like expertise in those. For example, this PCR was for powder coating. And you see, Sherwin-Williams also are on the committee, which is great. They volunteer their time to share their experiences. So when this PCR is developed, I'm the LCA scientist, can help, what should be the system boundary, data quality, et cetera, and they can really help with okay, how many layers of powder coating we should consider? What's the base layer? So much technical aspects goes into the system that if we don't consider it in here, different LCA scientists can develop that model differently. And then at the end of the day, you can compare this powder coating with that one, because the whole point is comparison. And in PCR, we give all the rules. What is the product group? What is the system boundary? What is the declared unit? For example, here is 1 kilogram of powder coating produced, powder coating product or layer. And then we have different information that these are all open access, you can download and read it. So why we need PCR? It's the ISO requirement. We cannot develop EPDs without EPD part 3 without PCR. In order to have consistency, in order to have credibility and compliance and comparability, it is critical. We need to compare apple to apple. And what PCR standardized? They standardize functional unit. For example, for that fenestration PCR I showed you from NSF, it says the functional unit is 1 meter square of window. It gives me the system boundary and models. Am I modeling from cradle to gate or cradle to grave? If I'm doing cradle to gate, my other part are optional or mandatory? It gives information to me to model it. Data sources and the quality of data I need to have in order to develop EPDs. For example, there are EPDs that says there are PCRs that says you need 12 months of consecutive data for your electricity in order to develop the EPD. What are the allocation rules? I'm producing 2 products and I need to allocate my electricity to these 2 products. Am I considering mass allocation or economic allocation? For example, sometimes when it comes to agriculture system, we are producing corn and we have corn residue or corn straw that is used to produce paper. So is it a mass allocation or economic? Depends, right? Depends on the system. So in PCR, it needs to be defined. Cutoff criteria, for example. What is cutoff criteria? Because we are modeling, right? We try to model the system as close as to the real world. You might tell me that, this part of the manufacturing all across Canada for window, only like it's minor, only like impacts 1% of the production, or the mass is just 1%, but the data is very hard to get. The PCR can say if some part of the manufacturing only impacts 1% of the mass or 1% of the potential impacts, you can exclude it from the system, for example. Or the PCR might say, do not include the infrastructure, in the impact of infrastructure into these EPD, something like that. And then what are the assumptions when it comes to scenario? Should I consider 2 layers of code, 3 layers to do some different scenario and disclose it? And what impact assessment method do you need to use? This is impact assessment is for LCA scientists. We have different methods like Tracy, CML, each of them might give us different numbers, right? Because they have different data in them. So it tells us, okay, everyone must use, for example, Tracy, and then we run the model based on that. And then what's the reporting format? What do I need to report in the EPD? We have different types of EPDs. Some PCRs allow industry EPD. Some PCRs do not allow industry EPD. So we have industry-wide EPD. We gather data from all the manufacturer, and it says this is the global warming potential for our industry in Canada. And then we have regional. We gather all the data from, for example, for Metro Vancouver region, and we run LCA model based on that region. It becomes the global warming potential, or EPD, of this. Then we have product-specific EPD, which way better, because you are going to have the global warming potential for your specific product, instead of your friend in another manufacturer might have more global warming potential in their product, right? But when you do regional or industry-wide, you are having those data into the whole EPD. So product-specific EPDs. And then we have product and facility specific. Imagine you're producing same product in Vancouver factory and in your Calgary one. Everything is the same, but the electricity grid is different. So in Vancouver, you have BC Hydro, and then in Calgary, your electricity grid is based on fossil fuel, so it's gonna have more environmental impacts. So product and facility specific data gives you closest number to your accurate data. Does that make sense? Okay. So these are EPD format and content requirements. General information. You need to disclose what's the manufacturing, where is the location of manufacturer, what is the product name, and also who is the program operator for this EPD. Because when we disclose the program operator, we are following the general information of the program operator as well. Some program operator doesn't allow, for example, white label. Some do. So this is important. PCR reference, the most important one. Sometimes people tell me, okay, these EPDs are not comparable. I'm like, are they following same PCR or not? If they are not following same PCRs, definitely you cannot compare them, because each PCR has different rules. So the other things you need to pay attention, are the PCRs same? In EPDs, we have declared unit or functional unit, reference service life, how long your product lasts, system boundary, life cycle modules. Are you only talking about A1, A2, A3, which I'm going to talk about those stages, or not? And then we have methods and results in EPDs, like what methodology we use as a LCA scientist, what's the geographical or temporal representativeness of the data, and if your product has biogenic carbon, if it's like wood, how I'm modeling that. They all need to be disclosed. And most important one, you need to see the name and signature of the third-party independent verifier. If the APD is not third-party verified, it means that company developed LCA themselves, they self-declared it, and it's not type 3. Type 3 must be verified by a third party. There are EPDs out there that they are self-declared. You just have to know what's the difference, what's the reliability that you can have on their data. So here is an image to show you what is this cradle to grave, cradle to gate in EPDs. When we say this PCR is cradle to gate, it means we are only reporting A1 to A3. A1, extraction of raw materials, transporting all your raw materials to your manufacturing, and then making the product up to the gate of manufacture, packaging it, and it's ready to go. Versus if it's, for example, cradle to grave, you have to report to whom you are selling. For example, is 80% of your product is sold in Metro Vancouver area and 20% is in Albert. Then we need to calculate what's the average transport. And then when it's installed, how you're installing it. Does it need repair? What's the maintenance, replacement, refurbishment? What's the energy use? Like, for example, in the window, like, what's the operational energy based on your window? How much energy we are losing in here? So water use, you don't need it, but for some product we do. And then what's happened at the end of life? One important stage that I'm gonna talk in detail is the replacement one. When you only consider cradle to gate, you are not considering how many times your product is going to get replaced. What's the durability of your product? But when you are disclosing cradle to grave, replacement matters. Because if you are replacing twice, 3 times, 4 times, the numbers is going to add up for the total global warming potential over a life of the building. It can be 60 or 75, depends on different standards. And PCR tells you that what should be the life of the building. And then if you are recycling or landfilling, again, at the end of this building, how many times you are going to recycle your products if you are replacing it more and more. So I put some imaginary number in here. Let's assume the A1 is 41. For a building service life that is 60, and a window life is also 60. So when you are building this building, windows are there, you are not replacing it anymore. And that's the blue column. Then you're having another window that the life of a window is 30. So over the life of this building, you need to replace this window again. Let's say A1, A2, A3, everything of these 2 windows are identical. But one window is getting replaced 1 time more. And that replacement numbers come from A1 to A5 and C1 to C4. Because you have to produce that product again, transport it again, recycle the previous one, or landfill it. And then total number of the global warming potential of your window over the life of a building is almost double. So replacement does matter. Durability does matter. But it depends how you are modeling the system. But I also understand the current PCRs, it's written on it. The reason that are only considering A1, 2, and 3, because that's a challenging part. In the PCR, it's written because it can, you can use different materials in order to install. Yeah, they skip it overall. But you should sit on those committees to improve it, to improve that PCR. Because the whole point of life cycle assessment is a whole life cycle thinking. Here we go. So now we are going to look at some EPDs to see what they are doing. And I just found these. They are open access. You can download them. So this is a PVC window, and based on what I mentioned, we should look at, we see the logo of ASTM. It means the program operator of this window EPD was ASTM. It is verified by one of the verifier of the ASTM program. And then it says this EPD covers 6 types of PVC windows, etc., and follows that ISO. Great. Then in all the EPDs, we have general information. We have product name, program operator, the important one, declared unit, 1 meter square of PVC window. So for all those 6 types, declared unit is 1 meter square. And then what is the period of validity? Because the EPDs expire after 5 years. The PCRs also expire. So sometimes some clients come and they want EPDs, but there is no PCR for it. So we have to develop a PCR. Or there is PCR for it, but the PCR is expired. We can't use it, right? So PCR is really important. So period of validity of this EPD is October 2025 to October 2023. What type of EPD it is? It is a specific cradle to gate EPD. So it's a specific product. And then reference year is 2021. That PCR says that the oldest the data can be is 5 years. So they published this EPD in 2025 and the reference year is 2021, so it's good. And then you can see verification is done externally, and you see who reviewed the PCR. This is an important one I forgot to mention. So when we develop the PCRs, then we have like also PCR reviewers that they review it and give us comment to even improve it. And here we have like Dr. Gloria, who got his PhD from Harvard, review that PCR for us. And then this is the PCR that they follow to develop this EPD. NSF as program operator, PCR for fenestration assemblies. So what products are covered in this EPD? We need to mention in detail. And they put a picture, great. Technical specifications of the PVC windows provided, great. So product description, these are all mentioned because the PCR wants it. So if you see some information, you want to see some information that's not in those EPDs, maybe in the next round of PCR development, you should be there and say how important it is to have this information and make it mandatory. Because when it's mandatory, the person who is developing that EPD must put that information in it in order to be verified. Okay. So it says PVC profile, sealed units, double glazed, the hardware is stainless steel components, etc. So here you see the compositions of PVC windows. So these are all type of information that when you develop your EPD, you need to provide to the EPD developer. So here we have production stages of the PVC profile at the thermoplast and extrusions plant in Quebec. Let me make it bigger. Okay. So they put the location, and you can see kind of a system boundary from virgin PVC. They have recycled PVC, they have extruder, etc. What's like, where does the material coming and what they are considering, the packaging, and then manufacturing stage information is provided in here. What is the packaging type? And here you can see the methodology used for life cycle assessment. As I mentioned, what else here? We have system boundary, A1 to A3 follows the PCR, because PCR says A1 to A3 is mandatory, A4 to A5 is optional, and also D, which is the benefits and burdens beyond the system boundary, is also optional. So they didn't do any optional, they did the mandatory. So this is the full system boundary. It starts from production of raw material. So the right section highlights come from the PCR. So I just wanted to copy paste to see like what data PCR asked and why they are including it, because of they have to. So the PCR says the material acquisitions, pre-processing, intermediate processing, and processing stage, production stage, starts when the raw materials are extracted from nature and ends when the intermediate materials like aluminum, glass reach the gate of the production facility and are processed into the final, in which they have also typo, product, and package of shipping. I say international product and package for shipping or something like that. During production, the product undergoes the transformation from intermediate material into the final fenestration assembly. So these are the information needs to be included in the MPD. Do we have those information? Do you know where those products are coming from? So A1, PVC scrap generating system. Production of raw material for the PVC profiles, and then production of raw material for other window components like glass, stainless steel. And then they had all those information. What's the transportation look like? They are transporting their PVC, they are transporting their glass and stainless steel. A3, the PCR cell says suitable data quality assessment frameworks include the information obtained from the manufacturing processes shall be average annual values per declared unit, and it shall not be more than 5 years old. So they declare it's not more than 5 years old either. Any secondary data that is used shall be less than 5 years old. If data older than 5 years is used from a secondary source, justification shall be included to address why newer data are not available. So these are the key information that we have to mention in the LCA report for verifier to read it. And for the manufacturing, as you see, they mention all the ingredients: PVC, production of natural gas, electricity, propane, water, metal for equipment, packaging, and then what's happening in the manufacturing, like extruder, die, haul-off, saw, packaging, etc. And then they have wastewater, they have waste, they have carbon metals. They also included transport of components to the assembly. As you see, transport of PVC profile, double glazing, stainless steel components. So they gather those materials for producing their final product. And then assembly of PVC window. So important part, assumptions. In here, they tell you that this number you see in the table, why you see that number, based on these assumptions. Modeling of double glazing. Separation of double glazing impact, etc. Again, these are all public access. You can read them, compare them with PCR, understand them more. Cutoff criteria, the important one. They are following the rules and says all input and output flows whose mass and or energy and environmental impacts account for more than 1% of total cumulative mass or energy or impacts have been included. If the PCR would have said, oh, the cutoff is 5%, they might have not been including so many things that you have seen in the system boundary if it was less than 5% mass or energy or impact. But the PCR committee, like manufacturer association, who have sat on that committee, deemed suitable that 1% is good. And then we have allocation rules. Okay, here the EPD is talking about data sources and quality. For the foreground data, the data that you are going to provide to the EPD developer, it says primary foreground data was provided by thermoplast extrusions between October 2022 and November 2025 for the year of 2021. This includes measured data concerning the manufacturing of PVC profile used for window frames and their packaging, the composition of PVC window and their packaging. And then they also have secondary data, which comes from scientific report and PCR, for example, for distance. So the distance one, transport one, is sometimes challenging. Some of these PCRs are mentioned in North America. And some of the distance data are coming based on EPA, which is American-based, not Canadian-based. So there is a gap in the default transportation for Canadian system in the PCRs, which hopefully in the future we are going to have some sort of default numbers. When in the situation that we cannot have access to data, we can use the default number. And then we have background data that says it comes from EcoInvent version 3.9.1 database. These are like very technical LCA things because like these databases gets updated. Like right now, I think EcoInvent is 3.12. So which version you are using or what database you are using, you might get different environmental impacts. So background data also does matter. And if you are comparing this EPD with another EPD that instead of EcoInvent, they are using Gabi database or US LCI, the assumptions of those databases might be different. So it makes it not really comparable, maybe. We have to review. So these are all the rules that can go into PCR to make sure EPDs are comparable. And here at the end, we have the famous table that everyone just look at it without reading the report and tells us what is the global warming potential of the A1 stage. It's 41 kilograms CO2 per 1 meter square of PVC window. This is for awning, PVC awning window. And then what's the A2 and A3? As you see in here, we can't say what's the total impact over a full life cycle because this is only cradle to gate. And here it's telling us what's the percentage of that impact coming from frame and how much is coming from the glazing. And where to find the EPDs. If you're interested to read more EPDs and see who has it, who doesn't, or when you publish your EPD, you want to see, okay, where my EPD goes. So EPD International has EPD library. You just search, find all the, here I put some flooring. You can search any product basically to see if they have EPDs. CSA group, EPD hub. As you see, each of them providing you with kind of different information. For example, here it says, oh, the country is Canada for this EPD. They put manufacturer name. We have a smart EPD. Again, you can search, find EPDs. We have ASTM. They listed all their EPDs and also PCRs. So the takeaway. Know which program operator you want to go with if you have a preference. But not all the time comes to preference. Sometimes comes to money, most of the time. So they have different prices. You have to pay to develop your EPDs, and then you have to pay to verify it. And sometimes you have to pay to program operator annually to have it. But depends. Like, for example, for ASTM, it is only around 6,000. Verification and having it forever on their website. But then there are other program operator that could be over 5 years up to like $17,000 because they charge you annual fee. On top of that, they charge you for verification separately. Product category rules. We found out the importance of category rules. then life cycle assessment, all the science at the heart of our EPD. Then we have EPDs. We learn about them. We know the importance of verifier and how to publish a EPD. And thank you so much for listening to me today. Please let me know if you have any questions around EPDs and LCAs. And
Yeah, Mike. Any questions for Shiva? Anybody? Oh, Otto.
Thanks for that. What you mentioned Bill C-59.
yes,
Yeah. So is that being written into any building codes? Is that like, okay. So there's no actual requirement for EPDs that are connected to the actual building requirements through the building departments. It's all just for things like LEED and stuff like that.
Basie, could you please come here and answer all the policy related and standard related questions, because I don't want to say something that might not be fully accurate.
Yeah, you bet. It depends on what the material is. So right now, for steel and concrete, if you're going to be constructing for a Government of Canada project, then absolutely you need to have an EPD. And then when it comes to the more voluntary programs like LEED or NRC's like whole building life cycle assessment, then you don't necessarily need an EPD right now, but the data that they're pulling from is from EPDs. So we're seeing a push towards the EPDs becoming a requirement.
Yeah, and I can add a little bit more to this. So the 2025 cycle included operational carbon as a requirement really across full buildings, which is different than call it the embodied carbon side for our products. On the 2030 cycle, they are genuinely considering adding component level EPD requirements for products. It's a lot of why, so we're working through the project for NRC. So we've essentially got our proposal in. They've agreed that it will work as far as just general first stroke. But a lot of the work we're doing is going to be informing the information necessary for them to look at building code improvement for 2030 or building code implementation. Well, I think the industry will argue what an improvement looks like, but.
So these are primarily cradle to gate type of EPDs? Yeah. So if it comes to cradle to grave, I'm seeing some issues around like how do you determine that when you're talking about life cycles that could be 50 years, like we were talking about with insulated units, that type of thing. So that would be really challenging anyways. So I don't know if there would be tests that could be accepted as being, for prorating performance over time, that kind of thing or something. But
So yeah, speaking to that a little bit, NRC, when they came to us, obviously, because they're really focused on this cradle date for 2030 code, I also had raised our hand from the Fenestration Canada perspective and said, durability problem. It's like, if we're going to focus on this, you're going to miss a major component that actually makes us viable in this conversation. So there's a separate project with NRC where we're working through kind of the beginning of that durability conversation around products. So what's happening in the background is I'm working through a phased approach with NRC on what it looks like to establish kind of a test methodology, kind of a failure state. Some the IGU conversation we were having earlier, it's actually incredibly timely, where that NRC in the background is working on establishing what that failure state is. And then how do we extrapolate, the tests necessary to determine how durable that product is within its lifespan? Like if the product goes in 10 years, what kind of tests can I do to say it still has 40 more years to go before this thing is failing? So we're working through that. And so that's kind of like a phase one, is establishing the test method and then extrapolating that across the rest of, gaskets and hardware and profile. And that's a whole nother bailiwick. And then it's the establishing of the standards necessary to incorporate that into the code itself. What I see is there's going to be a long gap between the truth of getting those test methodologies in place and then implementing it in such a way that durability becomes a fundamental conversation. But frankly, the embodied carbon conversation, and I think probably agree, it doesn't work without the durability. Full stop. Like, this doesn't work. So I think we see it. I'll continue to pursue that. We'll continue to reach back out to the membership and collect feedback. I'll be honest, this is one of those topics that is very top of mind for me, and it's difficult because it is such a long timeline kind of project. And so I think for most manufacturers, it's like, what does next year look like is like the best question I can ask. And like 15 years from now is brutal to even like, but some of these things just take that long, honestly, to go through, and we'll at least start plugging away at it in the background so that when we get there, hopefully there had been some work done so we're not caught by surprise.
And also hope if we're doing all this work here in Canada and North America, that we're sort of making sure that anybody that's importing anything is subject to the same standards.
Yeah, Terry and I were just in the Fensterbow, and I was talking with IFT Rosenheim on that same topic, that there's a little bit of, how do we create as an association, not necessarily just these relationships with the US, but as an association, where else would you like for us to establish it? I think like IFT Rosenheim is one of the most respectable research groups in the world. I would love for them to be more involved so that they understand, their membership understands what it would mean to work in the Canadian market, and ideally there's some alignment on best practices. But anyway, sorry, I've kind of
Go for it.
Good. Other questions?
I wanted to talk a bit about the replacement, and you had a chart up there that showed this 30-year versus 60-year. And from looking at it briefly, I kind of came to the terms that it assumed that the product would be replaced in 30 years with the same product that was installed 30 years ago.
Exactly.
The same technology. I do a lot of work in existing buildings and work with a lot of homeowners, stratas, multifamily buildings that look at replacing their product. And in fact, government incentive programs incentivize homeowners to replace product before it's failed because of modern technology. So there's two parts to the replacement industry that I think needs to be really considered. One is people will replace product before it's failed, before its life cycle is met, because there's new technology. And we don't know what that technology will be 30, 40, 50 years from now. So we're assuming a life cycle that we actually don't know. Because 10 years from now, we might have technology that blows it out of the water. That means we're replacing all the windows we put in today 10 years from now. And we don't know what that's going to look like. And if government incentivizes homeowners to do it preemptively, we kind of got a bit of a conflict. So I have a 20-story building that's looking to replace its double glazed, no low E, thermally broken curtain wall system from the 80s, only because modern technology is available to reduce the heat gain coming into the building. The building's overheating. So thermal comfort is the driving factor for replacement, not energy efficiency. Well, a little bit of energy efficiency, but not product performance from a failure perspective. So I worry about how we deal with cradle to grave when we don't know how to pinpoint the decision-making from a homeowner when it comes to the replacement industry. Yeah. Because its evolution over the last 50 years has been quite dynamic. It's not linear. It's all over the map. So
Probably that's why the current PCR is A1 to A3, because it was so challenging to have it.
Yeah. Well, and I mean, to speak into that a little bit on the durability side, if we don't create durability metrics in our industry, how are we ever going to run towards targets? Like, we're not going to care about that portion. The consumer won't have incentive. We won't be able to create programs to incentivize that if we don't have some metrics around how durable our products are and how we test for that.
That's a really interesting point. Should incentives be driven by multiple factors and not just by, oh, you're going to get 30% savings on your energy bill? Well, we know that's not happening, but that's what happens. You're swapping out, like you say, 10, 15-year-old windows that are perfectly serviceable because there's a government program that incentivizes it, and renovators that are selling promises that may or may not be accurate. And people are throwing away perfectly good windows. Yeah, it's happening all the time.
Thank you for the presentation. I have a question. As I know that City of Vancouver, the embodied carbon report is mandatory. do you ever, any other city in Canada, it has mandatory reports for the embodied carbon?
Policy and the standard people. I'm the scientist one.
None that I'm aware of. Not today.
City of Calgary. If the city is funding, I believe it's 33% or more of the building, then yes, they have a guideline that you have to follow, which eventually falls back on NRC's whole building LCA guideline, which is the same one that City of Vancouver falls back on. So it just depends. It's really hard to keep track of. I try to knock down a city when I'm bored on the weekend and try to stay on top of it, but
Adrian, do you recall if TGS, Toronto Green Standard, do they have anything in there?
yes.
Do they?
Yeah,
Okay.
they do.
Yeah.
Yeah. So there's
Because they reference Vancouver.
yeah, there is a baseline in the Toronto Green Standard as well, and then financial incentive if you're able to beat it.
Okay.
Thank you.
Good to know.
Yeah. Shiva, nice to hear you speak again. It was always a very interesting presentation to get my head around.
Thank you.
Anyways, I'm thinking about it from the manufacturer perspective here. Certainly coming out of COVID, we know that everybody's got, A vendors and B vendors, and I started thinking about as you were going through on some of this reporting, what if I have one, my primary vendor is in Mississauga, Ontario, but my B vendor, the backup, is in Mexico or is in some place like that. So how does that make it into this documentation? Because I don't think you can really flip back and forth depending on where this window operator hardware came from. Is this about the worst case scenario or is it about the better case scenario?
So over a year, for example, my question for you would be, let's say reference year 2024. What percentage of your material comes from A? And what's the percentage B? And then we do weighted average. Yeah.
Yeah, but it's a great question. Like I feel like it, and this is going to get into a little bit of the nuts and bolts of what I think is actually going on in the background with the embodied carbon side. Is in Europe, as they have established this further, it's acted as a trade barrier. And so, you can essentially isolate your market a little better if your transportation costs in carbon are intrusive to your market expectations. And so if you've got product coming from China or from North America coming into Europe, that becomes disincentivized in their market because they track for that carbon. I think that's a portion of the game that's being played here. So it is something to keep in mind. I think us as manufacturers, this is going to be a tough one just because I think the A1 through A3 doesn't immediately benefit us. There's going to be some stuff we learn that I think is valuable to overall industry process, but not to the point that we're going to want to participate in this. That's my gut feel. But if we don't, I think we're going to leave ourselves vulnerable to that problem later on, which we essentially become a dumping ground because we don't have that trade labor put into place.
But that's the beauty of LCA. It keeps your hands open. Like I can run the model assuming that your A, all the materials come from A. And then assuming again, all the materials come from B. And then do sensitivity analysis to see, okay, what if in the other year, 60% come from here, 40%? It's like we can run the model and you can see the numbers that what would be the worst case scenario and the best case scenario. And we can report it because you see the numbers. So.
I see we have few different CO2, SO2, other ones. Is nuclear waste going to come up to there? Because nuclear energy is really picking up. And my fear is that if we miss that, we will probably have nuclear dump grounds more than the carbon that we're dealing with right now, and probably with a bigger impact. So it's
a great question.
Yeah, in the cumulative energy demand method, we are considering all type of energy. So it is reported in some LCA reports, but I don't think if in the PCR is mandatory, but that can be maybe a mandatory part in reporting all of this. And like in here, I even focus on global warming potential again because all the attention is on global warming potential. But when I was educated at the university, like 10 years ago, they would tell us, do not focus only on global warming potential. You are doing burden shifting. What if you change your strategy, reduce global warming potential, but increase acidification, eutrophication? So we are still at the first stage, like there are so much challenge, but yes, if you are a conscious producers, you have to pay attention to all of the impact categories.
Yeah, and it's also further complicated because the fuel that you use in the nuclear fuel is typically created by energy investment into a natural resource. So let's say you're trying to use element X, which is not naturally existing. So you have to take an element B and invest energy into it to make it more radioactive so you can actually create active nuclear energy out of it to create the compound. So it can have multiple layers. Like you could have hydroelectric or carbon-based fuel, creating nuclear fuel, fuel creating energy to create the product. So as you said, yeah, it can be very complicated. And yeah, industry just needs to start thinking about it. And scientists like you are very critical to that because, yeah, it's not a straight game. It is going to be very, because nuclear energy driven vehicles are coming next, right? Like that is something that has been talked about, that can vehicles use nuclear fuel? And if that is something that comes up in next, let's say 30 years, so where do we go with that? So
Great questions.
As long as Tiger Woods isn't driving the nuclear.
That's right. Yeah. A nuclear reactor crashed on the side of the. Yeah, that's not good. Is that good? Are we good? One more? Okay.
One more.
One more.
It's Victor Kowalczyk, in Fiberglass. Thank you, Shiva, for the presentation. Actually, I brought your agenda on one of my presentation lately. And my experience, I just want to tell you, it was to one of the largest builder of the long-term care facility. And I believe provinces are funding in many occasions those long-term care facilities. So after talking about the ICU and all the durability of the product, that particularly vice president of this company said, Victor, I don't have any obligation to put the best product in my project because I'm selling this in 2 years. I have an obligation to my shareholders to show the highest profit. So I will not take it from you. So now my question is to those who are making policy, either the city, province or so, is there any pressure to put this as the policy, like some of the cities are already going with this policy to look at the durability of the product and long cycle assessment? Thank you.
Thank you. Do you want to add?
Yeah, I can touch on that one. Thank you for highlighting that. So I come from a quality management background in construction, and basically we don't do anything on what I would call the upstream end, right? So, you know, when we bid a job, we're bidding it with these materials, but when we actually build the job, we built it with these materials. Right now, whole building LCA is assessing what is planning to be built, not what is actually built. And I think that's kind of what you were alluding to there. Now, the only, so LEED, for instance, LEED goes on what you built. You get a plus or minus 10% allowance. So that's the only certification that I'm currently aware of that's looking at it from a downstream perspective. What did we actually put into the building? I personally think it's going to signal closer. You know, this could be 20 years from now. It could be 30. It could be 5. Who knows, right? But I think they are going to shift towards what we actually built versus what we plan to build, if that makes sense.
Well, on policy side, what I've seen, obviously building code is one thing where I think there's some staging there where we're going to see that information eventually migrate into the minimum requirements for our buildings. But also in the budget last year, there was no concept that seemed to repeat itself more than the government's focus on carbon. Like that was a huge piece for them, is the decarbonization. So, it's almost like I have to view this from the lens of we're at a maturity stage 1 through 5, and we're really at 1 right now.
Yeah.
Makes sense. It kind of like I feel like I'm such a guy with a hammer right now, hitting everything. Everything's my nail, but durability. It's like if we're not thinking about this stuff long term, if we don't have metrics assigned to how we think about this long term, short term gain is always going to kind of win out, right? So yeah. So I guess I've just got a couple comments and a question at the end. Obviously, the work that we're going to do with NRC, the point of it is so that we could clarify the background data. Whether it be European data that's coming in or North American data that's coming in, Canada doesn't have a lot of its own fenestration data. So that is a big point of that project, is so that we have some level of control over, those black boxes, and we have evaluated them appropriate for our market, so that you guys as manufacturers, if you're going through the process, you're not asking yourself, why does this data look like this? Because it's not reasonable. And there's some truth. It's like, the fact is we need to unpack those boxes. So I'm really grateful to NRC for coming to us and offering to pay for this process. That I think what we'll get out of this is somewhere between 8 to 10 LCAs that look at the materials, product types, whether it be, aluminum, wood, or UPVC, fiberglass. But that's kind of the point. I love your comment on PCRs. Obviously, as we kind of talked through this project, that was going to be one of those big things that we as an industry are going to have to participate in. Specifically to like Jagdeep's comments, this is a gap. There's no way for us to fix what we're talking about with energy without participating in the PCR process, because as we learn more, we're going to figure out that there's stuff that doesn't work, and not just because they didn't work from the beginning, which I'm sure there's things there, and we've kind of talked about that. It's like where the data sets are coming from and how reliable they are probably needs to be cleaned up. But there's also things as the energy uses change and what becomes important to this. Like that's going to have to be our voice. There's serious work to do on this subject. So my question, we're going to go through this process in the background. How important do you guys think it is for us to have an industry EPD at the end of that? Like, it's something that's not currently included in, call it, the pricing with NRC, but we as an industry, maybe we need to be considering paying for taking the data that we create and creating an industry EPD. What would that do for the industry that will not happen with the data that we get from the LCA from your perspective?
So when they decide to develop their product-specific EPD, they can compare it with the industry EPD to see how they are doing at the industry level. Are they more than the industry average? Why? Are they doing better than industry average? Great. Can they still improve it? That can be one of the usability. And the other thing, like for other people who really want to like just see, okay, what's the window situation in Canada looks like versus like Mexico or like Europe. So that's another usability of it. Having something is better than nothing, right?
Yeah, great. But the LCA doesn't give us nothing. Like, we will have data from it, but it's not summarized and terribly usable. Like, it is one of the deep flaws as I like work with government, is oftentimes have this plethora of data. But using data and then creating information is just such a different deal.
But like the majority of LCA data is confidential. I think that's a problem. Like, we have great data in the LCA reports that if I put my LCA report, someone else read it, another LCA scientist can model the same model that I did because every detail is on it.
Yeah, totally.
But then EPD is just a fraction of that report that we could have out there. So there are so much discussion in LCA community because like I'm also a member of like American Center for Life Cycle Assessment. Like everyone is working to improve even the methodology, how to disclose it, who should be a verifier, because so much also discussion on the LCA section. But if we don't measure things, we can't manage it. And at the moment, like we just need some data to see what's going on. So later we can manage it.
Yeah. Just to add something on yours, I think on having some industry APDs will give us, like you said, some data. I'm trying to figure out how to put this all together, but we've lived in a country that's kind of put manufacturing, blacklisted manufacturing, and to have something to justify and to say back, like, this is why we want to be responsible for our own resources. But to focus on this project, once the NRC thing gets going, we're going to need participation from the membership. When I'll reach out to you, those that are willing to participate can reach out to me. I know we'll work with Build Neutral. We partnered together on this, basically taking their expertise in EPDs and LCA and ours in the industry to be able to create these data sets. And so we will need help. And it's I just remarked yesterday from our provincial meeting, so much of what we've done as an industry has been retroactive. Something has been specified in a code that nobody knew what the knock-on effect was Windows. This is one of the few times that we're ahead of the curve. We really have the opportunity to go back and say, this is what our industry is prepared to provide and what the standards are. So I'm really excited about it. But when you see the requests from myself or Shiva, don't just throw it into your junk box, because the participation is going to be key to getting relevant data and correct data.
Yeah, just one more advantage of industrial EPD came to my mind for manufacturer. EPDs are pricey, right? That's one of the reasons so many manufacturers don't want to get it. If it was for free, I'm sure everyone would want an EPD because they can use it for marketing purposes. Their logo goes into the industry average EPD, and they can still use it to show their client that we contributed in this industry average EPD, because their data is going to be in it, their logo is going to be on the first page of the industry average. So that's another advantage.
That makes sense. And just to kind of tag on to this, there's going to be a task group as this gets started. So that'll be a bit of a guidance task group for this. So as we're collecting data, we'll be sharing it with that group, and it'll provide kind of a place where our membership can participate in this process. But to the point, there's going to be manufacturers that are needed in order to actually participate in the data collection, which is a different deal. So I'll be working with this team to make sure that goes out to our membership. But yeah, if it goes into your junk mail, please reach out so I can help figure out how to make that better.
All right. Well, thanks, Shiva. Appreciate
Thank you.
Great presentation.
Thank you so much.
Thank you so much. Appreciate it very much. All right, so that's our schedule for today. I want to thank our speakers. There was some great content today. That was some really interesting stuff. Thanks to our sponsors again. Can't do it without them. Our exhibitors, thank them for coming out. And we'll see you in a couple of weeks at FenCon in Winnipeg. And Opera Software has been good enough to put a bar outside the door. So join us for a cocktail for an hour. I think it goes till 6. And we will see you at the next event. Please reach out if you need some help or if you want to participate. We're always looking for people to get involved. Me, Adrian, Cam, Rich. Who else is here with us? Jeff out there, Lane, Steph, Lee. We love what we're doing, but we can only do it with your support and your help. So, Rick, we're going to talk some more. All right. Thanks, everybody. Safe travel wherever you're going from here, and we'll see you.